Hello YouTube, my name is Toby, and today we're going to figure out whether toothpaste can compete with thermal paste. It is a well-known fact that toothpaste can work as thermal paste, but however, for how long is it useful? To answer this question, I decided to test a rig for 10 hours just to see how well it fares. This rig consists of an Intel i3 2100 dual-core CPU with a TDP of 65 watts. I believe the clock speed of this CPU is 3.1 GHz at full power. Before we get to the fun part, we first need a baseline using regular thermal paste. I used RealTemp 3.70 to monitor the temperature and ran a few programs just to see how high the temperature went. During my testing, the CPU never went beyond 45 degrees Celsius, and thus our baseline has been found. For my remaining test, I'll be using the built-in CPU burner in Thermon. Now let us change out the thermal paste with toothpaste. As you can probably tell, I applied a generous amount of toothpaste. I was unable to run the rig for just 10 hours straight, since I do have other things going on in my life, so I had to divide it into 5 parts that I'll refer to as logs. Log 1 ran for an hour and a half. The temperature seemed to settle at 43 degrees Celsius, which is actually 2 degrees lower than our baseline. But this is probably just due to the large amount of toothpaste I applied. After a while, there seemed to be a minty smell in the air, but after about an hour or so, this turned into a slight burnt smell, which later went away. Log 2 ran for just 1 hour. Not much happened during this run actually. The temperatures seemed to just settle at 43 degrees Celsius, and there were no odd smells in the air. Log 3 ran for 4 hours. During this time the temperature started at 43 degrees Celsius, but it slowly started to rise. It didn't rise much however though, as it seemed to settle at about 45 degrees Celsius by the end, which is equivalent to the thermal paste that was on there before. Now between log 3 and log 4 I was out of town for 5 days. Had some stuff going on that I had to take care of, and thus I was unable to run the experiment for 5 days. However, log 4 ran for a little over 2 hours. At the beginning of this run the temperature settled at 45 degrees Celsius, and towards the end it was stable at 46 degrees Celsius, with a single spike to 47 degrees Celsius. So it seems the toothpaste is starting to lose its cooling powers a little bit. Now once again, between log 4 and log 5, 7 days went by where I was unable to continue the experiment. This again, I had other stuff going on and I just couldn't find time for the experiment. However, log 5 ran for an hour and a half. At the beginning of this run, the temperature was stable at 46 degrees Celsius with a single spike to 47 degrees Celsius. By the end, this didn't change. It was still 46 and 47 by the end of the run. So I have to say that I was positively surprised actually by the toothpaste. I expected the end result to be much hotter, but right now I am curious to see what the toothpaste looks like after 10 hours as thermal paste. So let's take the heatsink off and take a quick look. When I got the heatsink off, the toothpaste seemed to have turned into some fine powder instead of a paste. It seems that the toothpaste powder was stuck to the CPU, since the heatsink seemed to be much cleaner. However, cleaning the CPU was no issue, just some rubbing alcohol seemed to do the job. I don't know the electric conductivity of toothpaste, but I'm very sure you do not want it on the PCB, so be careful when you clean it off. So what did we learn? Well, it seems the toothpaste is a viable option even for extended use. At least with a low power CPU, I think you might run into some issues if you try this on a hotter CPU though. But that is another experiment for another day. And I really hope you enjoyed this video. Thank you very much for watching.